Tutorial sheet 4, question 8. It's a superhet question which says it's a superhet receiver having an RF amplifier and an IF of 450 kHz is tuned to 15 MHz. Calculate the Qs of the RF and mixer input tune circuits, being identical if the image rejection ratio is to be 120. So we're going to have an antenna going into our mixer. So this is the situation we've got. However, that antenna also includes a filter, and so does the mixer. So essentially what we've actually got is our antenna going into two filters before it gets to our mixing stage. And the overall effect of that filter is to have an image rejection ratio, which I'm going to call alpha, which has got to be equal to 120, and that's made up of alpha 1 and alpha 2. So alpha 1 is equal to our usual equation, 1 plus q squared 1 x squared, and alpha 2 is the same, but this time we've got different Q factors. However, the question says that these two circuits are identical, so that the Q factors are identical for each situation. And we also know that any signal coming through here is just going to be, this is essentially a gain stage. So what we're going to have is a signal coming through here is going to be multiplied by alpha 1 and then multiplied by alpha 2. So alpha 1 multiplied by alpha 2 is going to be equal to our final rejection ratio, which is 120, which is going to be equal to 1 plus q squared x squared, because it's just these two multiplied together, and we're assuming that q1 is equal to q2. So if we rearrange this, what we're actually trying to get is an equation for Q. So we've got Q, if we rearrange this equation, is equal to the square root of 119 over x. So we need to calculate what x is. So from the information we're given, the RF frequency is 15 megahertz. And our IF frequency is 450 kilohertz. So our local oscillator, and the question also says, assume that the local oscillator is below the RF. So our local oscillator frequency is going to be the difference between these two, which is 14.55 megahertz. So our image frequency is going to be our signal frequency time add twice our IF frequency, minus twice our IF frequency. So we're going to get 15 subtract 2 times our FIF, because the local oscillator is below the RF frequency, and that gives us 14.1 megahertz. So then we have to work out, so we know what the image frequency is, we know what the signal frequency is, we can then work out what x is. So x is equal to f image over f signal minus f signal over f image, which is going to be equal to 14.1 divided by 15, subtract 15 over 14.1. If you work that out, you get equal to minus 0.124. Well, we're not actually interested in the minus, because in the equation that you start off with, x is squared anyway, so we're actually only interested in the magnitude of x, which is 0.124. So we can use that in the equation that we've just derived here. So q factor for each filter has got to be equal to the square root of 119 divided by 0.124, which is going to be equal to 88.